Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2021. The question is based on the topic of capacitors, RC circuits, but like again a fairly simple question. Most of the students would have done this without much hassles. The question is again based on paragraph type question, which IIT had called STEM this time. Uh, there were two questions based on this paragraph. Both questions were of 2 marks. So total marks awarded for this paragraph was 4. So let's see what's happening over here. Initially, the switch is in position P. That means switch is joined like this, and we have to find the charge on the capacitor in steady state. After a while, the switch is now brought to position Q, and again we have to find the charge on the capacitor in the steady state. So Q1 is the charge on the capacitor when the switch is in position P in steady state, and Q2 is the charge on the capacitor when the switch is in position Q in the steady state. So we have to find the value of Q1 and Q2. So very easy question. Let's draw the circuit when the switch is in position P. So in that case, this wire is useless. So we can say that this is how the circuit is going to look like. This is 2 volts. This is 1 volt. This is 1 ohm. This is 2 ohm. This is 1 microfarad. So you can see in the steady state there will be no flow of current through this wire because capacitor would have been fully charged. So there will not be any charge flow. So the current will be 0. So in that case we can say that current will be flowing only in this circuit, in this loop. So net EMF is plus 2 and minus 1. So we can say that current here will be plus 2 and minus 1. That means net will be 1 volts divided by 2 plus 1, 3 ohms. That means 1 by 3 amperes. 1 by 3 ampere. Okay. Now we can find the potential difference, and the current, by the way, will be in this direction. Now we can find the potential difference across this 1 microfarad. So if you try to start from here, then 2 ka rise, okay, and 1 by 3 into 2, that means 2 by 3 ka drop. That means we can say that if this is point A and this is point B, so this is VA minus VB is 4 by 3. Okay, so VA minus VB becomes 4 by 3. So we can say that the charge on the capacitor Q1 will be 4 by 3 into 1. Okay, so this becomes 1.33 microfarad. 1.33 microfarad. Microcoulombs, not farad. My bad. Microcoulombs. Okay. Similarly, if you talk about when the switch is in this position, like when the switch has come in this position Q, then let's draw the circuit here. The capacitor will be like this. So you can see that this is 2 volts, 2 ohms, 1 ohms, and 1 microfarad. So 1, 2, 2, and 1 microfarad. Okay, this battery will go out of the circuit. Okay, now in the case of steady state, again there will be no flow of charges through this wire. The capacitor will be fully charged, so we can say that there is no flow of charges whatsoever. So current will be flowing in this direction, in this loop only. And if you call this current I, so that I can be straight away written as 2 upon 3 amperes. Okay, now it's very easy to see that the potential difference across again the same point AB will be 2 by 3 into 1. That means it will be 2 by 3 volts. Okay, hence we can say that Q on this will be 2 by 3 into 1 microfarad, which is nothing but 0.666, which can be truncated to 0.67. In this case, we were required to write the answer in 2 places of decimal. So the answer will become 0.67. Right, rounded, we were required to write round off till 2 places of decimal. So this, you can see, is a very easy question, a regular question, and most of the students would have done this without much problems. That's it. Thank you.